Hey guys, welcome back to another video. Today, again, we are going to be playing Universe Sandbox 2. And today, we are going to terraform Mars. That's right, what people in NASA and stuff are planning, I'm going to do. Because I'm so smart. And I exactly know how we're going to do this. What we're going to do is a couple of things that you will see in a minute. So the first thing is, well, we gotta like make Mars bigger, alright? Now, let's just do this the fun way, right? Let's slow time down. And let's grab, we'll grab a random small moon, right? We'll launch it. And fire in the hole. I missed. Boop, bonk, boop, boom, 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 boom. Yay, this is fun, isn't it? Random moon. Bow, 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 bow. This would take yeah, this would take a lot of meteors if we were gonna do this. Because we'd just have to grab some from the asteroid belt, like down the street of Mars, Martian Street. But it would take a lot to get Mars really hot. So we're just gonna launch the moon at it. Bonk. Boom, boom. It's a losing mass because everything's escaping. Well, that's not good. Boing. It's probably just because I'm speeding it up, but... Boink. Yeah, it's losing mass. Okay, how about we just throw Titan at it? Oh, that's bigger. Oh god. Why is Titan bigger than the moon, or Mars? That doesn't make sense. Well, it probably does, but I'm just stupid. Why is Pluto in the asteroid place? I guess it's not really asteroid, it's just minor. Wow. Mars is almost as big as Pluto now. This would not really be classified as a planet anymore. Because I can't. Like, why? Let me just launch meteors at it. They won't throw as much debris. Alright, this would take a lot of throwing things at Mars. I still think it's throwing off too much debris. Let's see. It's not really doing anything. But the radius is going down, so I know something's going on. Alright, so evidently we can't do this the legit way because physics. Yeah. We're on a time limit here. So let's just open up the solar system and go to Mars. Mars? I meant Mars. Alright. I'm eating an ice cube, don't judge me. Alright. Yeah, you'll probably judge me because I'm eating ice, whatever. I don't have very sensitive teeth. Anyway, let's just go to Mars, not the asteroid, I meant Mars, okay. And we'll just make it like, I don't know, half the size of the Earth. There we go. Next thing we need to do is go to climate and greenhouse effect. We need to just bump that up, like, a lot. Because the surface temperature of Mars is really cold. So, yep, it still needs to be bumped up. That's, okay. It won't go up any more than that. I think we need to do atmospheric mass. Let's just make that half the Earth since it's half the size. And it should hold on to that atmosphere pretty well. Alright, and I think that means that we can go and up this. Can we? Hello? Nope, it doesn't work anymore. Alright, isn't there like carbon dioxide that I can pump into the atmosphere? I watched Spike Viper and like he can do it, and I don't know how. I need to watch this video again. Cause like if you've seen this video, he like pumped carbon dioxide into the air to try to save the Earth. But this just won't work. It just doesn't. I don't know why. Alright, anyway, the next thing we need to do is give it a moon. Now, like, the moon is pretty important for Earth, but not that much. It just creates tides, which we could really live without. It doesn't, all it does is just, like, kill people whenever stupid kids bury them in the sand and then don't unbury them. So, alright. I can't see anything. Well, it's more like the Earth, at least that's good. What? Okay, hold on. Real quick, we need to see what the what is it? Magnetic field, how many gauss it is. Okay, third, so we're gonna go 0.150. I'm pretty much just like making everything just like half of Earth. This is just gonna be a half of Earth. It's just gonna be like if you cut the the Earth in half and it just mold itself back into a ball. This is what it would be right here. Alright, so now it's got a magnetosphere, which is good. You can see it's nice and weird looking and stuff, and it looks like it's going straight towards the sun. With what I do with what I do with things, it probably is. Alright, we still need to up the surface temperature, but the thing is, how? Because, oh, I know. It's gonna turn down the light, or the Earth likelihood, but we need to turn this down. This is how much it reflects light. So we need to turn that down, and you can see that, oh no, it's actually more like Earth now because it's warming up. But, yeah, the Earth has a lot less of that albedo, or whatever it is. I don't know what it's actually called. But what this does is now it's absorbing, and it's actually getting hotter. So we also, real quick, need to give it more iron than silicate because with the Earth, it has a molten core which creates a magnetosphere. And we need a core that's about that big. That's good. Maybe a little less, like 20%. Let's see, Earth. It should be about, ooh, the Earth. Oh, wait, that's the mass of the Earth. I forgot. Okay, so that should be about what that is. And there we go. We have something that's strongly resembles the Earth. Well, not really in looks, but alright. The next thing that we need to do is give this water. Now, this is going to be a pain in the bumhole because you've got to get just enough that you have a land mass. And that's difficult. Alright. What the? Oh, there's some mass. Okay, I thought that was like meteors hitting it or something. I'm like, how did that happen? Alright, so we have a couple of land masses, but we still need to make continents. And there we go. That should be good. Maybe a little less. Now we have some continents. There it is. That is Mars there, ladies and gentlemen. It has one major supercontinent. We're going to call that Pangea V2. Even though, like, they all have different names and stuff, but whatever. Alright, let's actually put it at, like, 100 or 1,000th of a percent. Alright, there we go. Now, the Mars that we all know and love is now more similar to Earth. It actually has a 56.4% of life. That's cool. It'll actually show lights if there is life on the Earth. Or on Mars. Alright, look at the surface temperature. It's almost perfect. Alright, so yeah, it's half the size of Earth. It's pretty good. Does the Earth have any hydrogen on it? I think it does. Well, I mean, I know it does, but I want to see if the game registers it. Yes, a tiny, tiny bit. Alright, so let's just like up that and then just go way, way, way down with it. There. That's about how much hydrogen the Earth has. Something like that. Okay, 92.6. What if we just go boop? Well, that 92.4. Okay, needs more. I think that's what it needs. 92.3. Okay, let's put it down more. That should be pretty close. Oh, it's just because it's going into winter right now. Ooh, okay, we're gonna have to turn down this a little bit more. Just 0.04 instead. So, okay. So now it's a little less, and the average temperature is still pretty cold. Like, it's going down right now. Let's add Earth right here. Select. Alright, you can see the difference. The Earth is at a pretty constant temperature. So, but now, yeah. Alright, let's kind of speed up time a little bit. Yep. So, it would be pretty cold and chilly for anyone on Mars. Earth has a pretty average temperature, but because of its tilt and it's like I know it is elliptical, but it's actually pretty straight. So, yeah, it's gonna be pretty cold. If you were here, I wouldn't want to be here because it'd actually be kind of chilly, like 24/7. So, it'd be a good old just above. The heck is that? Okay, sorry, there's like a bunch of crap in the background for some reason. Just had to yell at them for a second. What even? Oh, that's the helicopter. Yeah, we have like a hospital behind us, and there's like, yeah, it's kind of weird. The next thing I think we need to do is move it a little closer in. Now, this we're gonna do legitly, and how we're gonna do that is we're just gonna take a random small moon, and launch it, and slow time way down, and then we're gonna launch it at the planet. Now, the planet, it's really cold. It's actually half or it's like half solid, so that's bad. It's not actually. Let's just take a pretty big asteroid. Actually, I know what we should do. We should just fire. Where is it? No, okay. What the heck is this? Shoemaker? Okay. Where's the comets? I mean, it should be in minor, but it's not. Common, I guess? Just give me a sec. I don't know. It's gonna launch the Halley's Comet at it, but alright, let's just go boop and boink. Now let's look at its motion. So speed is 21.1 kilometers a second. We just want to slow that down a little bit. But alright, let's take a random small moon. That should kill its velocity. Is it? Is it gonna kill its velocity? It doesn't seem to be doing that but we want it to do that, so let's kind of speed time up and see what happens. Alright. Its orbit just kind of got elliptified at this side. Yeah, guys, please tell me how to say that, because I have no idea what it is. Yeah, all it did is kind of fire it off to the side. Now it's kind of speeding up. Now there's bigger seasons. Alright. Now it's getting farther away. Okay. Well, that didn't work. Let's throw another random small moon at it. It's gonna slow time down. Alright. We need to slow down Mars. So we're just gonna launch this pretty fast at it. At like 50 kilometers an hour. 50 kilometers, well, 50 kilometers a second, not an hour. Boop. Oh yeah, in one of my other videos, I kept saying, like, what was it, like, instead of me graduating high school, graduating college. So, sorry about that if you cringed at that. So, in 2025, I'm graduating high school, not college. Alright. Alright, so it's still not slowing down its velocity at all. So, well, what we can look at real quick is its temperature. We can look at a graph. So it's going way up now, and now it's crashing to be really, really cold. Like in the negatives, and everything gets frozen over. Then it gets warm again. And it gets pretty hot. It actually gets hotter than I would like it to be. Let's actually view the habitable zone. So it's just outside the habitable zone, except for this one side. That's actually kind of far in. But since it has such high, like, greenhouse gases and stuff, it actually gets, like, really warm. So it actually gets kind of close to Earth now that I'm looking at it. I really messed up the orbit there. We can look at its motion. So it gets 0.65 astronomical units away from it, from the sun. And then it gets, yeah, it varies a lot. So what we can do is kill its speed for just a second. We'll kill its speed and then pause it, right? And then auto orbit. Boop. There we go. Now it's a little farther in. It may have some conflicts with Earth, but the thing is, it's right in the middle of the Goldilocks zone. Even the Earth isn't. Actually, now that I look at it, the Earth's actually kind of hot. Like, it's almost inside the non-habitable zone. But Mars is perfectly in there. Like, if you look at it, it's... Let's see its temperature. Its temperature... Ooh, it's actually kind of hot now. Okay. Well, I have a fix for that. Just turn up this. One, oh, that's, okay, that's really, it's a lot of reflection right there. Okay, it's still cold. 0.25. That should be pretty good right there. Alright. We'll put it at, what, it needs a little bit warmed up, right? No, it needs a little, to be a little cooler. 0.3. Just like I need to be, a little cooler. But I'm a loser. Okay, anyway. So, let's kind of turn off this view. And wait, real quick, let's look at composition. Yeah, and then Earth similarity 93.4. Life likelihood is pretty high. Higher than it was before. And if we look at it, there is no stars. But, I mean, whatever. Anyway. So yeah, that's Mars right there, ladies and gentlemen. That would be kind of what it looked like if we terraformed it. It wouldn't have, well, it probably would have all those impact marks, but after thousands, if not millions of years, it would be beautiful and stuff. And I want to save this object, but I don't know how. Save this object. Perfect. Okay. Mars. But not. But with water and stuff. There. Perfect. Now, if I wanted to, which I do, what's that? Oh, launch, rings, my objects. And boop. Oh, I missed. Boop. It's not really habitable now. If we look at its composition, sadly, it's not like everything's dead. Let's just like launch a million of each other at it and see what happens. Now if we look at it, now it's pretty much the same because it was just smashing itself into one another, so it's a little smaller than it was before. We just wait for time to slow down. Other it being launched away from the sun, it's pretty fine, you know. Yeah, now we have a ton of planets to live on. Heck yeah. And now let's just, you know what we need to do. You probably don't, but I know what I need to do. What I need to do, right? Just take and go to sun, and then just go like, just do that, you know? Now it's a black hole. I'm pretty sure. If it wasn't, I would be kind of confused. Yes, it is a black hole, and then we just need to go to motion, and then speed, light speed. There. Bye! Oh, it's going the wrong way. Fail. Okay, hold on. I know how to do this, don't worry about it. Let's just go and take a small moon and launch it at 50 times or 5,000 times the speed of light. That way. It didn't phase it. It's not working. Okay. Well, anyway, guys, thank you guys so much for watching. And don't forget to like and subscribe and join my Discord channel. And I'll see you guys in the next Universe Sandbox 2 video. Bye!